Welcome back to Blue Collar Coder. It's another Tech a Day, and where normally we look at new technologies because we want to be better programmers and learn new things. Sometimes when you want to get better at something, you got to double down on the basics. So today we're going to take a look at ECMAScript arrays. Now, hold up. Before you go like, I already know all that. Okay. Do you have a one-liner that gives you an array with all the numbers between 0 and n? Do you know that the array can handle .keys and .values? Okay, well, maybe not. Let's go and jump in and look at almost everything to do with an array. All right, here we are in VS Code looking at a Quokka document. Now, Quokka is an interactive REPL for JavaScript, so I'll just be using that to work through all the things array here. And that starts by making just a very basic array, which is one of a couple of ways of doing that. So another is to use array.from. It takes an array or an iteratable and then makes a new array from it. So you can use it to make a pretty easy shallow copy. Or you can use it to coerce things that are iteratable, like the attributes of a DOM element, into easier to use arrays. Another option is to pre-allocate the array. So you do that by creating a new array with a count, and that just creates an empty array of that many items. And you can do some cool stuff with it, like use the fill method to fill it with a specific value, and then use map to turn that into an array of all the numbers from 0 to the length of the array by taking the index, which is the second argument to the map function, and returning that is the value for that item in the array. You can even just add 1 to it to make it from 1 to the length, well, plus 1. So to get the length of the array, you just have to hit the length property. Now, starting with accessing arrays, one way is destructuring. And here you can take the individual values off the array and assign them to locals. Like here we take the first and second values in the array and assign them to v1 and v2. To merge arrays, you can use the spread operator to create new arrays from 2 or more arrays, or you can use the concat method to basically do the same thing. I think spread gives you a bit more control. Now on to join. Join creates a string by joining up all the values with whatever the separator is in the argument. Here it is with a space, and then no space just smushes them all together. I use that for when I'm like formatting HTML together, like I have an array of tags as text, and then I use an empty string and a join to get them all combined into one big block of HTML with no spaces in between the tags. Next thing to look into is how we iterate over an array. So let's start off with an array of strings. And then we'll first try out the old school for in loop. Now the big gotcha with this one was that I1 in this case is an index of the item in the array and not the item itself, which is honestly, it was always bad. And so I think with ES5, we got for of, which is basically the same thing, but it gives you the item and not its index. But the new school way to do this is the for each method, which takes a function, and that function gets the item and the index as the parameters. All right, so now we're getting into the fun stuff, starting with map. So map is just like for each, with the exception that whatever the output of that function is gets stored, and then all of those get summed up into an array that's the output of the map. So here, the output of the map function is a new array where all the letters are turned into lowercase, and the letters array remains the same. So map is not a destructive function, meaning that it doesn't alter or destroy the original array. Other methods, as we'll get to in a bit, they are destructive. So it's good to know which ones are not destructive. So just like for each, you get an index as the second argument. So here we're taking the letters array and making a new array with just the index of each item in it for whatever that's worth. All right, the next one up is filter. Filter is like map, but it gives you a copy of the original array where items are optionally filtered out. So the function you give it should return a value that's either truthy or falsy. And if it's truthy, then that item goes into the new array. If it's falsy, then womp womp, you don't get to pass go. So here I'm going to pick out items from the array where the strings have an A in them, and now B. Now anything that's not an empty string. So reduce is an interesting one. The idea here is you start with a value and then you iterate over the array and then use each item in the array to change that value, and you pass that value on to the next item and so on and so on. We call that value the accumulator. The accumulator is the first parameter to that function, followed by the value as the second parameter. So in this case, I'm using A1 as the array that has 1, 2, 3 in it, and I'm using reduce to sum up those values. Here's another version using minus. And here I'm doing like a join. I'm basically taking the original accumulator as an empty string and then adding every string to it. There's actually a really cool pattern when it comes to sequentially doing promises that uses reduce. Kind of fun. There's also reduce right that does the same thing, except that the starting point is at the end of the array and then going towards the start. Does it in reverse. All right, lots of fun with that. Now on to flat. Let's create a new array that has two nested arrays, like a grid or a matrix, I guess. Now that's going to flatten it back into a single level array again. Now let's create another array that has an array of arrays, because we're just that crazy. Now flat by default does just the first level, but if I pass a depth argument, it will flatten to that depth. And here's its cousin flatMap. Now flatMap, despite its name, first maps and then flattens. So say I've got this array of records, and from them I'm going to pull the name field. Now that's exactly the same as map because flat didn't get a chance to do anything there. So let's instead make names into name into names. And now map returns an array of arrays. So let's try flat map. And now we just get names as an array. Cool. Finally, slice. Slice gives you either a shallow copy of an array or all the items including and after the specified index, where that's the first argument. Or if you've got two arguments, then the first one is the starting point and the second argument is the length of the slice that you want. All right, so far we've done a lot of iteration and some mutating to create some new copies. So how do we find stuff? Well, our first option is find, which returns the first item that matches what a specified function is looking for. So again, you're returning truthy, and if you then find it, you return truthy, and there you go. So in this case, the function is looking for C. If I do a find index with the same thing, then I get that back that C has an index of 2. If nothing is found, then you get -1. Another option is index of, which you just give a value and it gives you back the index. Super easy. You can also do includes, which tells you true or false if a given value is in the array. So now let's create an array that has some duplicates and find the index of A, which would be the first item in the array, as well as the last index of, which, because in this case there's 2 A's in that array, it's going to return the second one, and the index is 2 there. So that's how we get that. All right, now we're getting to the somewhat more obscure sum and every. Sum tells you whether any items in the array match the function that you give it. So here I'm asking whether any items in the array that has 1, 2, and 3 in it have numbers greater than 1. Turns out 1, a couple do, so it returns true, but not everyone does. So that's false. But if I give everything greater than 0, then I do get true because everything is greater than 0. All right, so thus endeth what I would call the functional programming set of methods on array. These are the non-destructive functions that return a copy of the original array. So now on to the destructive ones. Starting with some options for adding and removing from an array. Push adds an item to the end. Pop removes an item from the end and returns it. Unshift adds an item to the front of the array. And shift removes an item from the front of the array and shifts the whole array back. That's where it gets that name. And it also returns that value to you. In the computer science world, push and pop, shift and unshift are essentially your primary queue operators. And finally, we have slice, which you can give a starting index to and a count to it, and it'll remove those elements from the array destructively and then return them to you. All right, getting close to the end here. First thing I'm going to do is use reverse to reverse the array, again, destructively. And then let's try sorting it out to put its contents back in alphabetical order. And now that's one thing about sort. By default, it sorts alphabetically or numerically ascending. If you want to change that, then you have to add a sorting function. So let's play with A1, which has the array of 1, 2, and 3. Let's reverse it and then sort it. That looks good. But let's say we want to sort it in descending order. So we add a function that takes two values, and they should return, that function should return -1, 0, or 1, depending on whether A or B is before or after each other. All right, a few more things. First off, you can just ask for a string version using toString, and you get a nicely kind of formatted string that has commas in it. And then there's the interesting methods, keys and values. Keys gives you back all of the indices as an iteratable. So to turn that back into an array so that we can see it, we use array.from. Same thing with values, except that it returns you the values. I think these are here so that you can treat an array like an object without changing any of your code, since an object has keys and values. And the last thing I want to cover is chaining. This is where you cascade a bunch of operations one after the other. For example, let's take A4, which has a bunch of numbers, and then we filter that down to just numbers greater than 2, and then multiply those by 10 using a map. And this is a kind of common pattern I see nowadays. Sometimes it makes things more readable, and sometimes it makes things more complicated. It's also pretty easy to do things in a way that results in terrible performance, so you have to watch out for that. But it is very popular with the functional programming crowd. All right, so there was my tour of arrays for you. Let me know if you have any questions or comments down below. And of course, if you like the video, please remember to like it. If you really like the video, just hit subscribe and hit that bell, and you'll be notified anytime I put up a new one. Stay safe and be good to each other.